Welcome to our third video walkthrough for our assessment. This one is for our MAP3 assessment in January. So first of all, hope you remember to put your name on the front, because of course if you don't get the marks. Okay, now I'm going to zoom in and we will start with question 1. Now sometimes for some of you, these are going to be wildly obvious, okay? But I'm going to go through the process anyway, because even if we're sure, we should still take the time to make sure of each and every mark. Now, centimetres, we know that cent is 100, so we know there's 100 centimetres in each metre. So that means we're going to divide by 100, which means all we do is we take our 600 and we move the decimal point 2 places to the left, okay? So that goes to there, and that one's gone. Okay, so that leaves us with 6 meters. Here we've got temperature, and a couple of different ways we can do it. And again, I'm going to explain it. I'm going to use a number line for this one. Okay, so I'm going to start at -14, -12, -11, and so on. Let me know if I've miscounted. Okay, so we're going to start at -13, so we're going to start here. We're going to increase by 6 degrees, so it's going to get 6 degrees hotter, so we're going to go 1, 2, 3, 4, 5, 6 degrees warmer. So we're still going to be at a negative, but it's now -7 degrees. Okay, and again, we reckon about a mark per minute. We've done these in less than that. So even when we take our time, we're still doing all right, but it's better to make sure of the marks. Question 3, and it's a grid. Now it's a 10 by 10 grid, as we can see. Okay, I'll do the same down there. And being a 10 by 10 grid, we know it's out of 100. Okay, and we have got 3 lots of 10, so we've got 30 over 100, and we know that is 30%. Okay, just move that up so we can see the answer. Okay, that's simple, but again, be careful. Here, different type of grid, but we are still 10 squares across. Okay, and we've got those there. Now, 2 different ways. I can look at it and I say, well, I've got 2 out of 20, or I can ignore the bottom row and I say, well, I've got 1 out of 10. And if I've got 1 out of 10 shaded, I can scale that up and I can make that 10 out of 100. So if I look at that again, that's 10%. Okay. On the calculator, of course, if I'd have counted these up and I'd have got 2 over 10, I could have done 2 over 10 times 100, and that would have given me my percentage anyway. Okay, that's question 3 done. Question 4, into algebra. And of course, if they throw algebra in this early, that generally means they're going to be quite straightforward. 1 mark, so 1 step. So we've got, and I'm going to show you this as the function machine because we've been doing this a bit this year. So I've got x divided by 5 is going to leave me with 8. So to reverse that, instead of divided by 5, I'm going to times by 5. So 8 times 5, and that gives me 40. So that means x equals 40. Okay. For b, we've got a 2-step equation. Okay, same again. I'm starting off with x. This time, I've got 2 steps before I get my output. So I've got x. I'm going to times it by 3. Take away 2, and I'm left with 13. So I'll do the reverse again. I do 13 plus 2 to give me 15 in the middle, and then instead of timesing by 3, I'm going to divide by 3. So 15 divided by 3 leaves me with 5, so x equals 5. You might not have seen this method before, but I find it works quite well, and it breaks it down. Okay, and it still counts because we've still got our midpoint as well as our end point there. Okay. Now this one, work out 5 over 4 as a decimal. Now we know change them into a decimal, we're going to do top divided by bottom. So I could do 5 divided by 4. 4 goes into 5 once, with 1 remainder. It goes into 4 goes into 10 twice, with 2 remainder, and it goes into there. We've got 5 times, so we end up with 1.25. But of course, it's calculator paper. So what we have to do is remember how to switch these things on. We can just put 5 over 4. Now on these Casios, there is no SD button, and I bring this up because these are the ones that exams have bought a lot of. So if we need to change that fraction into a decimal, we press format, and on the screen we can change that down into a decimal, and there we go, 1.25, the same answer we had before, which is good. Okay. So, question 6, and it's a bank statement. And the thing is, these are getting pretty outmoded now. Most people have got these, they've got the banking app, they don't get a written statement anymore, but this is how they work. Okay, so if you've got credit, this is money in, and a debit is money out, and the balance is the state of play of your account at the end of each day. Okay, so on this one we've got £924.37, and we're going to take out £650. So again, let's come back to our calculator. So I've got 924.37, and I'm going to take away 650, which is going to leave me with, and again I've got that silly thing there, so I can press that, change it to decimal, and it leaves me with £274.37. Okay, so that's the state of play once that bill's gone out. Okay, and it was red, that one. Now we get a refund of £35, and that £35 is added to this. So I haven't cleared my calculator, so I can just leave that up there, and I can add 35. Same again. So we now have £309.37, and then when we look at this, we get paid. Okay, end of the month we get paid, and this is how much they're being paid. So again, this is going to be added to this. So I'll leave that on my screen, and I can just add 2248.85, and then do the same again, change it across, and we've now got £2,558.22. Okay, now we don't need to put the pound signs on these because the pound sign is at the top of the table there. Okay, but if you do, you're not going to lose out. All right, that was question 6. Question 7, well, if any of you have ever tried a Sudoku or some other similar kind of puzzle, you might be used to these. So we've got some numbers in place already, and every column and every row will multiply to 280. Okay, and we've got these numbers left, 4, 5, 10, 14 and 20 to use in those spaces. We can only use each one once. So if I look at this, I've already got 2 numbers in this row, and I've got 2 numbers in this column, so I can work out which each of those are. And what I can do is I can reverse. We know that we're going to end up with 280. So if I put 280 in, if I divide it by 28, I'm left with 10, and then I can divide that 10 by 2, which leaves me with 5. So that means we've got there. So 5 times 2 gives me 10, 10 times 28 gives me 280. Okay, and don't forget, put a line through it so you know you've used it. Okay, going to do the same here. Now, slightly differently. Same again, I've got 280. I'm going to divide by, but I already know that 7 times 2 is going to give me 14. So if I divide it by 14 in one move, I get 20. Okay, and we can see that. So 20 times 14 will give us 280, and we're working okay then, aren't we? Okay, we've got 2 here on this row, so we can work out this last one. Now, similar kind of thing, 20 times 1 is going to stay as 20. So if I do my 280 divided by 20, I'm going to be left with 14. I'm not following my own rules there. I didn't cross off the other number. I crossed off the 20. Now I can cross off the 14. I'm left with 10 and 4 now. Okay. So now what we can do, I've now got one left on this column and one left on this column. So I think we'll go for this one again. 28 times 1 we know is going to be 28. And if I do 280 divided by 28, I am left with 10. Okay, and that one's gone, so we're left with 4. 4 must go in there, but let's just make sure. Okay, always worth making sure. So if I do 4 times 7 times 10, I get 280. So I know we're all okay there. Okay, and that's it. 3 marks. And generally on a mark scheme for the likes of that, if you get 3 marks for all, and then you lose a mark for each mistake. Okay, that's question 7. Now question 8. Looks horrible. Isn't actually that bad. Okay, I'm going to zoom out a moment so we can see the whole thing. So the graph is used to convert between pounds and ounces. We've got ounces on this side and we've got pounds on that side. The line is already put in for us, and that's the conversion ratio between the two. So the first question asks us to convert 48 ounces into pounds. I'm going to zoom back in. So when we look here, I've got 5 squares between my 40 and my 50, so each one goes up by 2. So that means 48 is going to be 1 square below the 50. So I draw my line across to where my line meets the graph, and then from that point I can draw straight down. Okay, and that gives me £3, so I can just put that in there now, £3. Okay, so that's the first part of that one. The second says convert £200 into ounces. Okay, and when we look at that scale, we are nowhere near £200. So to me, the easiest one to do is if I do the £2, I can then times the answer by 100, and that will give me my step. So same again, from your 2, come up to your line and come across. Okay, and that's 1 square above the 30, and we know that each square goes up by 2, so that's going to be 32 ounces. So we can then do 32 times by 100. Okay, and we do that, I'm going to do it here nice and easily. 32 times 100, and it's going to give me 3,200 ounces. Okay, nice and simple. Probably a lot simpler than they look, but make sure you show your lines because they count as you're working out on questions like this. Okay. Question 9. Estimation. Oscar is estimating the answer to 413 plus 1,684. And we're going to round it to the nearest 10. So basically, if I round that to the nearest 10, that rounds down. So we've got 410. And I round this to the nearest 10. Again, that rounds down. So I've got 1680. Okay. I'm going to do the same again. So now 410 plus 1680, and it gives me 2019. Okay, with these questions you're getting a mark for the rounding as well as a mark for that answer. Okay, so make sure you round it to the nearest point. And on the next part it says that Oscar thinks that my estimate will be less than the exact answer. And we want to know how he knows this without working out what the exact answer would be. Okay? And the answer is simple. Because we've rounded both of these down, so each of these is less than the original, we know it's going to be less. So we can say that it is because he rounded both down. Or words to that effect. Okay? And that will do us for that one. Okay, that's question 9. Question 10. We've got salaries. Here are the salaries in pounds of the 6 workers in a company, and we need to work out the mean. And we know by now the mean being the hardest to work out, what we do is we add them all together and we divide by how many there are, and we know there are 6. So we're going to add all of those and it will give us our answer. Now, let's do it. I'm going to do it with this one just to keep it basic, okay? So I've got 17,500 plus 26,000 plus 27,500 plus 27,500 plus 27,500 plus the last one, which is 141,000. Okay, I know which one I'd rather be on. So it gives us a total of, we've got 267,000, which we are then going to divide by 6. And we get an answer of 44,500. Okay, so that is the mean salary. Okay, and it looks a bit odd, and that comes into part 2 of the question, because it says, is the mean a good average to represent the salaries? And when we look at those numbers, okay, what we're saying here is the mean average at 44,500 is actually higher than 5 of the 6 salaries. Okay, so that doesn't seem to me to be a nice middle value, does it? And yet when we look, there are 3 values that are the same out of the 6. So I reckon that if we'd have used the mode, it would have been better. So what we're saying is we can say no, and we can say either way. We could say that because the average, the mean average, it takes longer for me to write this than talk, mean average is higher than most salaries, or we can say mode would be better. Oh, I'm saying beta there, that should be better. Good job I'm doing maths and not English. Okay, mode would be better. Either way, we're still getting the marks because we ticked the box and we've given a reason for that one, okay? Okay, so that is question 10. Okay, question 11. So we've got Cara's mass is 65 kilograms and we want to work out her mass in stones and pounds, so the old imperial measurements rather than metric in kilograms. So it tells us 1 kilogram is equal to 2.2 pounds. So first thing we need to do is we do 65 multiplied by 2.2 because there's 2.2 pounds to every 1 kilogram. When we do that, let's use this one for a change. 65 multiplied by 2.2 and we get 143. Okay, so that is 143 pounds. Okay, now what happens here is if we now know it in pounds, so we think, well, there's 14 pounds in 1 stone. So if I do 143 divided by 14, we end up with 10.214. Sorry, the calculator is there. Let me show that again. Let's clear it. So we had 143 divided by 14, and we get 10.214 and some more numbers. Okay, so let's show that. So we did 143 divided by 14 to give us 10.214 and some more numbers. Okay, now that's 10.2 stone. Okay, now what we have to be careful of is the calculator. As I've mentioned before, calculators don't understand decimal measures of 14 pounds to 1 stone. They only work in decimal multiples of 10. So it's actually 0.2 of a stone. It's not 2 pounds. And how we can look at that is we know there's 10 stone and each stone is 14 pounds. So if we do 10 times 14, we get 140. Okay, so that's £140 already used up. If we take that away, so we do 143, take away the 140, we are left with just £3 over. Okay, so I'll even doing that off the screen. So the 10 stone is £140, which leaves the 3 left over. So we have got 10 stone and £3. If you put 10 stone and £2 on there, you will lose a mark, okay? Because it's the way the calculator works. It's recognizing that imperial measurements don't work on a calculator, okay? So then we have question 12, and we're into ratio questions. So we're going to make squash from juice and water. So we've got juice and water in a ratio of 1 to 5. Always stays in the same order, okay? And how much squash can be made using 70 milliliters of juice? So that means the juice is going to increase up to 70. And we know to multiply 1 to get to 70, we're going to have to times it by 70. So we do exactly the same on the other side. And if we covered up the 0, we do 5 times 7, we get 35, and put the 0 back on. So we've got 350. Okay, so with 70 milliliters of juice, we need 350 milliliters of water, and together they make the squash. So we do 350 plus the 70, and again we've got our 0, we bring those together, we got that, so we end up with 420 milliliters of squash in total. Okay, and then part B, different squash, and we're going to make it from juice and water in the ratio of 1 to 9. So what fraction of the squash is juice? So we know the juice is just the 1, so that's 1 out of, and a lot of people at this point go, oh, put it as that's 1 to 9, 1 out of 9. But remember, it's 1 part of that plus 9 parts of that, so it's actually 1 out of 10. Okay, that's question 12 done. Question 13, we're going to throw in some algebra. So we're saying multiplying y by 4 gives the same result as adding 12 to y. So if we're doing y times 4, multiplying y times 4, we would just we'd have our y, but we'd put our 4 in front of it. Because remember, algebra, we don't write the multiply sign, so 4y is 4 times y. And adding 12 to y, we've got y plus 12, okay? Because we're adding 12 to something, so that is the original. And it says that multiplying y by 4 gives the same result as adding 12 to y. So that means they must be equal if it's the same result. And that is our answer. Okay? So then, part B says show that the value of y is not 5. And all we have to do is we can substitute into what we already know. So if we say the y is 5, we would have 4 times 5, which would give us 20, and we would have 5 plus 12, which gives us 17. Not the same. Okay, that's all we need for that one. That's question 13 done. Question 14, a little bit more involved. 5 marks, so we know we're going to need to see 5 steps. Okay. Now the important things here. We know there must be a total of 56 students. We've got the prices. We know that each minibus can hold 16 students. So if we do 56 divided by 16, I'm going to use this one again. 56 divided by 16, and we get 3.5. Okay. Now we can't have half a minibus, so we have to round it up. If we round it down, some of the students are going to miss out, so it has to be that. So 4 minibuses needed. Now again, as always with these, we see lots of space for all the working out, but you don't have to do everything there. I prefer to use it up here. We need 4 minibuses, so we're going to do price per minibus. We're going to multiply that by 4, And we need a driver for each, so I'm going to times that by 4. So that's going to give us those two numbers, okay? So again, let's work this out. So on our calculator, 115 times 4, and we get £460. And they all need a driver, so 179 times 4, and that gives us £716. Okay. So now, what we can do, and there's a few different methods around this, we can actually work out the cost of each game. So students playing 2 games, 56 students, but I'm going to divert around this one. If you've done it that way, fine, but I'm going to move around. First off, I'm going to find out the total cost for the minibus. So if I add those together, and I've got my 716 plus my 460, it gives me £1,176 total cost for the minibuses across all 56 students. Okay. Now I can now divide that by the 56, which gives us £21. Okay. So all I did 1176 divided by 56, and that gave us £21, and that's cost per student. Remember, you don't have to write these bits down, I'm just doing it as part of the explanation. Now, because we've done that, we already know the coach cost per student. We don't have to work out the total cost of all the games. All we know is each student is going to play 2 games. So we've got £6.50 times by 2 to give us £13, and we can then add that on. So we now have, I'm moving that down again, £21 for the coach plus £13 for the bowling, and we will end up with a total cost per student of £34. Okay. You could work out the whole cost of that. You could double that to 13, times it by the 56, add it to this, and then divide it by 56 to get the individual cost. I just found that was a bit easier, splitting the two things apart. Minibuses was one thing, the games were the other. Okay, so that was question 14. Question 15. An ordinary fair dice is rolled 12 times, and here are the first 11 results. And write down the probability of getting a 3 on the next roll. Now, a fair dice is still going to be out of 6. How many 3s are there on a 6-sided dice? There's only 1. The whole point of this is to check that you understand that the probability of each roll is a separate thing. The probability doesn't change. Each time it only has the same probability of getting a 6. Okay. So then question 16, a little bit of indices, but looks like a ratio question. So we've got R to W, and it is 1 to 5. Okay, that's our ratio. But they want the ratio of R squared to W squared. So we square each. What's 1 squared? Well, 1 times 1 is 1. And 5 squared, 5 times 5 is 25. Okay, and that's it, done. Okay, looks nastier than it is, that question. So knocking the tripod for the camera there. So question 17, we have a square drawn on a grid, two different questions. On one it's drawn a congruent square, and on the other it's draw a similar square. Okay, now if you haven't come across these terms before, congruent means the same, so same angles and the same sides. Okay, so that just means we're going to draw that square anywhere on this grid, and it is absolutely anywhere. Okay, it just has to be a square with the same sides. So I'm just going to put it there. Not even well drawn, but you're used to my drawings by now. But it's the same square, just somewhere else, that's all. Okay, you could have even had it right next to it. Doesn't matter. Okay, and part B is a similar square, which is not congruent. Similar means same angles, so it's still going to be a square, different sides. Now when we say different sides for a similar square, that means that all the sides are still the same size, it's just that they are different to this. So we could make it bigger, we could do 3 by 3 or 4 by 4 or anything, but there's nothing to stop it being smaller. So I'm just going to do it by 1. I'm going to halve it in size. Well, it's actually a quarter of its size, but you get the idea. I'm going to halve the sides. 1 times 1 times 1, and we're all done. That's simple, and that's why it's 1 mark. So congruent, same, it's the same shape. It can be turned round, but it's the same shape. Similar, it's basically the same shape, either made bigger or smaller. Okay. Yeah. Okay. Question 18. We've got a tub with 66 chocolates in, and they are milk or dark, and either have a caramel or fruit centre, and that's shown on this table. Milk or dark, caramel or fruit. So all 66 need to be on this table. Okay. And it tells us that 3 out of every 11 chocolates have a fruit centre. Now that does mean there's only 11 chocolates. Okay. We already know there's 66. So if we take our 3 over 11 and we scale that up to out of 66, what we've done, 11 to get, how many 11s in 66? Well, there's 6. So we're going to times it by 6. And 3 times 6 gives us 18. So that means there's 18 chocolates with a fruit centre. So that means the total for the fruit centre must be 18. If there's 8 there, that means that must be 10. Okay, that's our first step. And it says there are twice as many milk chocolates as dark. Okay. Now, we're splitting the 66 chocolates between milk and dark. Because it's twice as many, what we need to do as well, let's look at it as a ratio. First of all, sorry, but it needs to be. So we've got milk to dark, and the ratio, we know that there are twice as many milk chocolates as dark. So that means for every 1 dark, there's going to be 2 milk. Okay? So we have got, if we put it in a block form, 2 to 1. Okay? So that means we've actually got 3 parts. Okay? So of course, don't really need to do this, but we can. So if we take our 66 and we split it between the 3, we get 22. So that means there's 22 dark, and of course we can times it by 2 to get 44 milk. Okay, so that 44 is twice as many as 22. So there's our totals on this side. So milk should be 44 and dark should be 22. And knowing that, we can now work out the rest, can't we? Okay, just still trying to keep that calculator outside of that. I'll move that over because we don't need this bit now. That's done. Okay. So we know there's a total of 44 milk chocolates, of which 10 have got a fruit centre. So 44, take away the 10, we're left with 34. And of course 22 dark chocolates, take away the 8, and we are left with 14. And we can do this just to make sure. If we take our 14 and we add our 34, we get 48. So that gives us a total for the caramel centres. And then if we add the 18, it brings us back to our original 66. Okay, so we know our numbers are right. Again, you don't have to show those bits. It's just nice to do it just for our own peace of mind to make sure we're doing okay. So the table is done. Okay, and that's 4 marks just for the table. Okay, and there's bits, you know, that we've worked with. You know, we've done equivalent fractions, we've done a bit of ratio, and we've done a bit of subtraction. It's fine, we can do that. So then the next question: 1 chocolate is chosen at random. What is the probability that it is a dark chocolate with a fruit centre? So dark chocolate, fruit centre, and it's this one here. So there's basically, you've got 8 chances out of the total, which is 66. Okay, there's 8 dark fruit scented chocolates in the box out of 66. Okay, and they've done it that way. They gave us the 8, they've done it that way, so you could still gain a mark even if you didn't manage to do this table. Okay, so there's still ways to gain marks. It says, what is the probability that it has a caramel centre? And it doesn't differentiate between milk or dark, so what they want is this. There's 48 caramel centres, and that's out of the 66 in total again. Okay, sorry, I'm writing that off the page. So we said 48 caramel centres out of 66 out of that total. Okay, so hopefully that's made a bit more sense. 6 marks for that question, that was a biggie. Okay. Alright, question 19. Describe fully the single transformation that maps shape A to shape B. So they're saying it's just one thing that's happened to it, okay? Now, because they're asking you to describe the transformation, they're not asking you to do it, it's already been done. We've got to move that shape to there, okay? Now, some of you will know this straight off, but if you're not too sure, this is a good process, okay? So I've got a piece of tracing paper. If you haven't been given one in an exam, and you feel you need one, ask for it, okay? Better to ask for it and use it than not, and then we'll think, oh, I should have done that later on, okay? So basically, we've got our shape there, roughly drawn, and it's moved down, but it's also turned around, okay? And that's the word. We've turned it around, it's rotated, okay? And we can see there that it's rotated in that direction to the left, okay? So we've gone that way round, okay, anti-clockwise, so the opposite way to the way the hands on the clock turn. Okay, now we just need to know where it's been turned from, okay, because if we look at from here, from the point of the shape, and we turn it, it's obvious that that ain't it. Okay, so we can move down a bit, so move down to there, and we're nearer, but we're not there yet, are we? Okay, so if we go down one further, let me straighten that one up first. Always awkward when using these things. Straighten that up. Go down one more. We come down, and we're so close to it, aren't we? Okay, but we've now moved over to the left. So I'm going to move one over to the right. I'm at the centre of our graph, 0, 0, also known as the origin, and hey presto, it matches up perfectly. So what we've done is we've rotated 90 degrees anti-clockwise around the center of the graph, which is 0, 0. Okay, you can call it the origin or 0, 0, not the center, and that's it. So describe fully the single transformation. It is a rotation. Have to use that. Can't say it's turned. It's a rotation. 90 degrees anti-clockwise. Okay, around 0, 0, or you could put the origin there, okay? And the 3 marks for this, it's rotation, 90 degrees anti-clockwise, and around 0, 0, your center of rotation, okay? And that's your 3 marks for that one, for question 19, okay? Question 20, we're going to use Pythagoras' theorem to work out the value of x, and they give you the theory on the formula sheet. A squared plus b squared equals c squared, and we know that the longer side is c and the 2 shorter sides are a and b. So we're going to be doing 15.6 squared plus 13.3 squared, which is going to give us the square of the longer side. Okay, now if you've been unlucky enough to pick up a sharp, you're going to have to work out each one individually. So 15.6 squared, hang on, always helps if you turn them on, 15.6 squared, and then work out that, then add them up, okay? Pain, but if that's the calculator you've got to live with it, okay? The Casio, and I'm going to use the new one just to show, okay? Because again, we know exams have got a bunch of these ones. So I'm going to I can type it in exactly as it is. So 15.6 squared plus 13.3 squared. Wherever my square is, there it is. Okay, and again, on this one, just going to move it up a bit so we can see that bottom one. When we press XE, we get it in a fractional form, so we press format, down 1 to decimal, and then OK, and we get our answer there. And it's come up as 420.25, and that's centimeters squared because it's the square of the longest side. So we need to do the square root of 420.25. Okay, and again, save ourselves having to retype it. We can just press the square root button and we press answer, and it copies in the previous answer. So we've got press XE, and then of course format, down one to decimal, and that, and we've got 20.5. So we've got 20.5 centimeters, and that is our answer. Okay, on the line there. Okay, now because we've done it all on the calculator, the temptation is just put the answer down. Don't do it. It's 3 marks. We need the 3 steps. Okay, you don't have to show that bit. That's just to help you go through it and to remind you. But write it down by all means to remind you. 1 mark, 2 marks, and then you've got your answer. It's the process they're interested in. Okay, so if you just put an answer down, you will lose marks, and we'll see you again next year. Okay, so that's question 20. Question 21. Bearings. 3-figure bearing of B from A is 0.24, and work out 3-figure bearing of C from A. Now, it's tempting to reach for one of these. Don't. As it says, not drawn accurately. So we've got the figures, we can work with it. Now B from A, we're going to B, but we're going from A. So that means we're going in that direction. And we always measure bearings from north. We always measure clockwise, so in the way that direction that the hands of the clock move, and we always measure in 3 figures. So this first one here, this one is 24 degrees, but we write it as 0.24. Okay, now they want the 3-figure bearing of C from A. So again, we're working out from north to there, and we know this one, we now know this one. So 52 plus 24, and we should be able to do that one nicely, shouldn't we? So that gives us 6, that gives us 7, and of course it's a 3-figure bearing, so it's 0.76 when we write it, and our degree is already on there. Okay, so for our main assessment, that was it. End of mock assessment, and of course you had the option to carry on with those other questions to see how you got on, because of course if you can gain marks on a paper, it's always worth a go. So we're going to move on to that one shortly. So the extra part of this MAP3 assessment, if you got to it, some groups will have done a full paper, it's been expected to do a full paper anyway. So question 22, how many edges does a cuboid have? Now cuboid, badly drawn of course, but we have our front face, and it's a 3-dimensional shape. Okay, and of course we have our other edges there as well. So when we look, we've got 1, 2, 3, 4 on the front, 1, 2, 3, 4 on the back, and 1, 2, 3, 4 around the edges. So that gives us 12. Okay, and that's our answer for that one. Only 1 mark. You don't need to do the drawing, I've just done it to explain. Okay, so then we are on to question 23, and it's a best buy thing. Okay, 5 marks. 5 marks available. So what we're going to do is work out each one in turn. Now I'm going to save a bit of space. I'm going to do some up here and I'm going to do some down here. First shop, shop A, £3.19 each, and we need 8. Nice and easy. £3.19 times 8. So let's do it. Okay, cleared off our previous. 3.19 times 8. And of course we need to do the format button to change it, and we get £25.52. So that was easy, 1 mark. The next one, shop B, £3.82 each, but if we buy one we get one half price. Okay, so a couple of ways to do it, but first thing I want to do is work out my half price. Okay, so I'm going to divide that by 2. Okay, so again, nice and easy. I've got £3.82 divided by 2, and that gives me £1.91. Okay, and that is half price. Now if we're going to get buy one and get one half price, we can then do the full price plus the half price. Okay, so we take our, we've still got our £1.91 on there, so I'm just going to add my £3.82 on, change it into a decimal, and I've got £5.73. And at the moment you might think, well, that's cheap, but what we need is, that's for 2 batteries and we need 8, so we need to times that by 4. So we're going to do that £5.73 times 4. We'll just put a line under those so we can see they're clear. So our previous answer times by 4, and that gives us £22.92. Okay, so this one was shop A, as we know. This one is shop B. I'm going to put a line across there because this last one is going to be shop C at the bottom. Okay. So we get this one, we do packs of 4 for £14.60, and we get a fifth off. Okay. So you can just work out the old what's left to pay, but at the moment what I'm going to do is I'm just going to deal with it in the basic measures as we would normally. We're going to find a fifth, take it off, and then we'll work with it. So if we type in 1/5 times by £14.60. Okay, let's do this one. So we've got 1/5, move it to the right, times by 14.60, and that gives us, when we change the format, £2.92. Okay. So now I can do my £14.60, take away my £2.92. So here again, I'm going to do, on the calculator, I'm going to do £14.60, take away my previous answer, which was the £2.92. And that gives me £11.68. Now again, that sounds really cheap, doesn't it? But of course, that's only for a pack of 4. So we need to take our £11.68 and times it by 2. So still up, so times it by 2, change our format, and we've got £23.36. So when we've got the 3 prices all together, and we can see that one's £25, so we can rule that one out straight away. And between shop B and shop C, we can see that shop B is the cheaper. So shop B, total cost £22.92. Okay, sorry, I'll put that in, type that in. Now, it also says show working to support your answer. So if you put shop B with no working out, you're going to get nothing. Okay, you have to do it, and that's also why they put the total cost there as well, because you've got to have worked it out. Show it all. There's 5 marks. Okay, and if you want the marks, you've got to earn them. Okay, so that was question 23. Question 24. And we're given information here. We're given a trapezium first off, and we can see the sides are actually in kilometres, and it's the boundaries of the city, which is why it's in kilometres. Okay. And in the box, when they give you things in a box like that, it's just information. Okay. And we know to work out the population density, we take the number of people and we divide it by the area. So that tells me how many people are in a per square kilometre. But they already tell us the population density, and it's 7,940 people per square kilometre. So what we need to do then, to find the number of people, okay, which is in our question, find the number of people, we've got the population density, we need to multiply it by the area. So we have to work out the area of this. Now, a couple of different ways of doing it. I'll show you the proper way, and then I'll show you the slightly longer way. Now, here, if we're going to do area of a trapezium, we do A plus B divided by 2 times by the height. Okay. A and B are the two parallel sides, and by adding them together and dividing it by 2, we end up with an average length of the shape, and then we're going to times by the height, which is at right angles. Okay. So I'm going to do 16 plus 22, divide that by 2, and then times it by the height, which is 10. So let's put that in. So in the brackets, so make sure they're done first. 16 plus 22, close brackets, divided by 2, move to the right, and then we're going to times it by the height, which is 10. And that gives us, straightforward, no need to change it to the decimal, it gives us 190. Okay. And that is 190 kilometers squared. Okay. So I've done that in that pen, but I'm going to change pens now, because I'm going to show you the other method. Okay. And that is to split it into 2. Okay. So we've now got a rectangle and a triangle. We know the triangle is still 10k high. And if this is 16, we take that away from the 22, so we're left with 6 km there, and that one is now the 16 as well. Okay. So we've got those in place. So what we can do 16 times 10, which gives us 160 kilometers squared. And our triangle, we're going to do base times height divided by 2. So we're going to do 6 times 10, which gives us 60, divided by 2, we've got 30 kilometers square. So that's 30. The 160 plus the 30 gives us the 190 kilometers squared, same as the other one. Okay, so it doesn't matter which method you use, it will get you to the same point. Okay, sorry about that, knocking the tripod. So now we come back to this. We know the population density, so we can say that 7,940 people is equal to the total number of people divided by the area, which is 190. Okay, sorry, writing that all there. So the density, to work that out, we did the total number of people divided by the area to get that. So what we do is we do it the opposite way around. We do 7,940 and we multiply it by 190, and that will give us the total number of people. So clear that off. So we've got 7,940 times by 190, and we end up with 1,508,600. So 1,508,600, and of course don't forget to put that on your answer line, 1,508,600 people. Okay, and that's that one. That's question 24. Question 25, only 1 mark, but there's still a thing to do. So we're going to vote for head students in a school. To reach round 2, a student must receive at least 21 out of 100 of the votes. Okay, so the largest possible number of students that can reach round 2. We just need to see how many 21s go into 100. So if we do 100 divided by 21, so 100 divided by 21, and we end up with 4.7. Okay, just gonna have that as 4.7 for now. That's all we need to know. Okay, 4.7, but we can't have 0.7 of a person, so that means it can only be 4 for that one. Okay. Now for the same vote, so it's saying there's 300 votes in round 1, and Sam gets 120 votes. Okay. Now Chloe chose pie chart to represent the results, and she used this method. She did 120 divided by 300, then times it by 100 to get 40%. Okay, now, and that's the thing, they've set degrees there, I've automatically set percent, because we know if we do 120 over 300 times by 100, we end up with a percentage. Okay, because that's the same way we work out our test results, isn't it? The amount of marks you get out of the total times by 100, and that's your exam percentage. But for this one, we need an angle. So instead of multiplying it by the 100, it should have been by 360 degrees. Okay, so is Chloe's method correct? No. And I'm just going to say should have multiplied by 360 degrees. Okay, I could also say that multiplying by 100 gives a percentage. And it's up to us with these how we describe it, but it's got to make sense. Okay, because basically when you look at the mark scheme, it'll give you a couple of examples, but as long as the person marking it can read what you said and say, actually, yeah, that makes sense, you'll be fine, because it's all down to that point there. Okay, so that was question 25. Question 26, the volume of a prism. And the isometric grid just refers to the dots, and it's an easy way of doing it. Now, on an isometric grid, if we look at a line, each line between the dots is a centimetre. Okay. Now, if we look at that, we know that's 5 centimetres because it's 1, 2, 3, 4, 5 as we move along. So as we look up, we've got 1, 2, 3, 4. So 1, 2, 3, 4 centimetres high. And here we've got 1, 2, 3. Now if we do 5 times 4 times 3, we're going to end up with 60 cubic centimetres. But that would be for the whole thing. Okay, and we've got a block missing here. So you can either take that away, work it out, or take that away, or we can split it into 2. Okay. And this one, when we look at this now, this one is now 3 centimetres. And this one is 2 centimetres. So for this block, I'm going to call that shape A, and this one is shape B, because we're going to bring them back together in a minute. A is going to be 3 times 4 times 3. And shape B will be 2 times 3 times 2. Okay, so when we do those, 3 times 4 gives us 12, times 3 gives us 36, 2 times 3 gives us 6, times 2 gives us 12, and then we add them back together again. Okay, so that gives me 48 centimetres cubed. And again, put that, don't forget, put it in on your answer line as well. Okay. Okay, so that was question 26. Now 27 is all to do with speed, distance and time. So speed, distance, time. Okay, we've got that triangle there. So they're going to drive 237 miles. We know the speed for the first 4 hours and the speed for the remainder of the journey. They don't give us the time for that bit, and we want the speed for the whole journey. So we need to work out the two together, don't we? First off, because I know I've got the time and I've got the speed, I need to work out the distance. So distance is equal to speed multiplied by time. So that means my speed was 34 and my time was 4. So 34 times 4 will give me 136. Okay. So that means 136 miles travelled in the 4 hours. So that's 136 miles in 4 hours. This next part, we know that our average speed for the rest of the journey was 50.5, so we know the speed, but at the moment we don't know the time or the distance. But we know the total, and we know how far they've travelled already. Okay, so 237, take away 136, and we are left with 101 miles. Okay, and that's 101 miles to do. Okay, in the second part. So we now know the distance, so we need to work out how long it took them. So time is equal to distance over speed. The distance was 101 and the speed was 50.5. So when we do that with our calculator, so we do 101 divided by 50.5 and we get 2. Okay, so that means 2 hours. So that tells us that they've done 6 hours in total to do the 237 miles. So we can work out the average speed now, and we know the last one for this speed is equal to distance over time. Our distance was 237 miles and our time was the 6 hours altogether. Okay, so when we do that, we've got 237 divided by 6, and that gives us 39.5. And that is our speed. Average speed across the whole journey was 39.5 miles an hour. And that, when we check that against the originals, so 4 hours, first 4 hours we did 34 miles an hour. Second part was faster, so that means the average overall is going to be between those two. Okay, if you end up with something higher than the both or lower than them both, you know there's a mistake somewhere. Okay, so that's all the working out for that one. Okay, but remember that triangle. So that was question 27. Question 28. And this one was a bit nasty. I'm not going to lie, it was. Again, anything in a box is information. And the term to term rule, this is it. So we're going to double the previous term and add 5. So we start off, term 1, we start off with A plus 2. So for term 2, we're going to double it. So now we've got 2A. We double that to get 4, and we add 5 to give us the 9. 2A plus 9. Third term, we double it. So we've now got 4A. 9 plus 9 gives us 18, plus 5 gives us the 23, which matches. So that means our fourth term, which is the one we're after because the one's the first 4 terms, we're going to double that. So we've got 8A. And when we double this, we double 23, we end up with 46. Add 5, we end up with 51. So we've now got 8A plus 51. And it's the sum of the first 4 terms being a multiple of 5, okay? So the sum of, we add them all up. So I've got 8 lots of A, 12 lots of A, 14 lots of A, plus another, so that's 15A. And then when we add these up, it's the easy way. So we've got 2 plus 9 plus 23 plus 51, which gives us 85. Okay, so the sum of them all is 15A plus 85. Okay, now the thing is about that is they both the numbers end up in 5, don't they? So that means they are divisible by 5. So that means they are a multiple of 5. So one way we can show it, we can divide them both by 5, but we can show that by factorising it. I'm going to put that into the bracket there as a multiple because we're dividing. So 15A divided by 5 gives me 3A, and 85 divided by 5, well, let's have a look. 85 divided by 5, and that gives me 17. Okay, and we've put it in there because 5 times 3A gives us 15A, and 5 times 17 gives us 85. So we have proved beyond doubt that the sum of the first 4 terms is a multiple of 5 because we've done it there, haven't we? Okay. All right. So on to question 29. Nearly there. Last one. Just prove it says end of questions there. So last one. And we have got what looks like a graph question. It is, but we're not going to use a graph. We don't need to. The temptation is with a question like this is you think, well, all right, I can draw my own graph and I can mark off 1, 2, 3, 4 and so on. Trust me, it's not worth it. Okay. Coordinates, always x and then y. Okay, always in that order. So the coordinates we have got for this straight line, the first one is 216 and the second one is 731, and that also tells us not to draw a graph because you do not want to draw a graph that's going to go high enough to deal with those. Okay, and we want to give our answer in the form of y equals some mx plus c. Okay, now the m is the gradient, and what that means, for every time x goes up by 1, the y will go up by whatever the gradient is, and the c is what we call the intercept. That's where it crosses the y-axis. Okay. So what I'm going to do, I want to look at the difference between those two. If I look at the x's, if I do first off, highest take away lowest, I've got 7 take away 2, which gives me 5, and that's on the x-axis. And I do the other one, I'll do 31 take away the 16, which gives me 15 on the y. Okay, so that means each one of those has gone up by, it's gone up by this much. So I want to find out what the gradient is. So I'm going to take the y-axis, the 15, and I'm going to divide it by the x. 15 divided by that, by 5, gives us 3. And that's the gradient. That means for every one the x coordinate went up by, the y went up by 3. So we've got the first part, y is equal to 3x. Okay, that's the first part. We need the intercept now. And what we can do is we can substitute the gradient into our gradient, our x coordinate into there. So I know that if I look at that first one, if I've got 3 times 2, so I'm going to do 3 times 2 plus something is going to give me 16. Okay, so if I do 3 times 2, I've got 6. To get to 16, I've got to add 10, haven't I? Okay, so there's my, that's my intercept, plus 10. If I do the same for the other one, I can do 3 times 7 plus something, and that's going to give me 31. Now 3 times 7 gives us 21, plus the 10 gives us the 31. Okay, so that means we are absolutely right. Y is equal to 3x plus 10. Okay, so we didn't need the graph, just a little bit of working out. And let's face it, none of this we actually needed the calculator for. It's just there to be used. Okay, so I hope you did okay. And of course, you don't forget, we can always rewatch and go over things if we need to when it's revision time. So good luck, and I'll see you for the next mock.